Hi guys and welcome to a quick DevCast. Today I'm going to present a new utility that I created for texture packing in Unity, and I just published it. It's public under an MIT license, so you can use it and in your projects and modify it as you want, and I'm looking forward to any feedback. So let me show you what it actually does. Uh, we have this standard problem in basically in UI usually, because we don't pack these into atlases due to all these sprites could actually come from a different addressable. So as you know, in Unity you pack, or in other engines or projects you usually pack your atlases before you publish. So you already have these atlases inside as an addressable, or as an asset bundle, or as any additional external resource. But if you want to have multiple addressables that are separately on server, or you can modify dynamically in the runtime, you need to pack it yourself. There is a utility in Unity actually, but it's very limited in its utilization. So I decided to port my MaxRect packer from the Genome 2D engine, which I created years back, and it's actually quite fast. And I added some utility on top of it just for Unity and UI specifically. I will maybe build on top of this for other use cases inside Unity, but currently I'm focusing on actually packing textures for Unity UI. So as you can see, all of these are sprites. They are not packed into an atlas. They are separate assets. If you just check the frame debug, you'll see that all of these are a separate texture and so on. So I created a TexturePacker manager on this screen game object, and what it does, if I push back, is it will enumerate all the images inside the screen, a hierarchy, and then it will create a texture and pack all these textures into that texture, and then replace all the sprites existing in the hierarchy to basically target the new texture atlas, or the texture inside the texture atlas. So let me show you. If I push back, nothing changed, but it's already changed in the structure. This is a previewer. It's not really needed. I just created a raw image, which is a previewer for this, if you want to preview if your texture atlases work. So, but now all these textures are already packed inside this atlas and are referencing this atlas. So let me show you. Now we have a lot less draw calls. We actually have a single draw call for all these textures, because now they are in this atlas, and the sizes and pivoting and so on, and the nine slices work as intended, because they were just basically fitted to the new atlas, and all these draw calls are just for the TextMesh Pro. So there is additional functionality. Let me show you. If I just, for example, hide this game object, and for example this, let's run it again. If I pack it now, it will obviously not pack. It will be a lot less when it comes to size for the atlas, because especially the title graphics was too large, so it was a bigger atlas. Now it's a smaller atlas, because it will always try to fit to the best possible smallest resolution. But if I just enable this, and again I will invalidate, you can do it through code, but I have this nice little button here. It automatically added this sprite to the atlas. All the others were already mapped, so it didn't really go through that all textures. It didn't repack all the textures again. It just repacked this new atlas, this new sprite, and added it to the atlas. There is another scenario, which is if I add this, and it's a pretty big sprite, it will need to resize the atlas, or it will need to create a bigger atlas. What happens then is that it will create a bigger atlas texture and then pack all the sprites from the existing atlas. So even if you disposed the textures that you create, the first atlas, it doesn't really matter because it's not using the original textures anymore. It will repack all the rectangles from that previous atlas to the new atlas and dispose the smaller atlas. So and now it's packed into this bigger atlas, so all of these could fit. So that's pretty much it. There is one more feature that I added is that you can remove the unused sprites. Let me show you. Let's pack these. So I pack these, all of these existing. If I just remove this one and I repack even with remove unused, it will not remove the clock, even though it's not really here. Because for now I made an optimization that if there is no need to remove it, there is no work to done on the texture, you don't really need the extra space, it will not be removed because the removal itself would basically reinitialize the atlas and do the bleeding and so on. So it's not really needed to remove, but maybe I will add an option to explicitly remove it if you want it. I don't really see a scenario for this, but what happens if I enable the title and invalidate it? You now see that there was a new atlas created, but there is no clock because now it was removed because I did the work. I had to reinitialize the atlas. I had to create a new atlas since this graphics didn't fit to the first one. So now I could remove the clock. I no longer packed it into the atlas. I can add it anytime and it works. So that's it for now. You can also specify that if you want to pack disabled stuff, for example, as I enabled disabled all these objects, you saw that when I have this disabled, it will not pack images that it encounters because it knows that the image is there, but it's not enabled, so it will not pack it automatically. You can pack it. For example, if you want to pack something, you have a hierarchy of UI that's disabled, enabled depending on gameplay, and you know that all of these textures will be visible in some point of time. You want to pack it even though it's disabled by default. And additional stuff is that you want to clear textures because if I don't clear the texture, the atlas texture upon creation, it will already have a color. As you can see, it has a white color. On different drivers and hardware, it can have different colors and it can have different stuff from memory. And what happens if I just pack it now? Uh, there may be some color bleeding from you can see it actually here. There is this color bleeding from this uninitialized stuff. So you may want to clear it to alpha. You may say that if there is a color bleeding, wouldn't they bleed from neighboring texture if there was some other sprite? Yeah, that's why I added padding. So you can specify, for example, amount of pixels for the padding. And now if I pack these you see that there is a different padding. There is a lot of space between them to avoid color bleeding. The internal packer I'm using that I ported from Genome 2D can actually have a different padding amounts for different sprites. So you can maybe feed some sprites with different padding, so it takes less space instead of using one general padding. But that's for you to specify on a deeper level. This is, for example, stuff that the Unity packer doesn't have. So you can specify it. I also think about porting the extrusion which is basically it extrudes the bordering pixels of the texture. It's sometimes useful for some use cases, at least it was in Genome 2D, but for now it's not there. If you see a usage for the extrusion as well, let me know and I will port it as well. So that's that. It's on GitHub, on my GitHub. I will post it under this video, and let me know what do you think, how you use it, and any feedback basically is welcome. Thank you.